continuing on from that last problem, I got cut off, so it's going to be, we had Q2 over Q1. Essentially, we're just solving for D, 2 minus D all squared. Right, so we just take this, we want to solve for D, so we square root both sides, so then we have Q2 over Q1, square root is equal to D over 2 minus D. Then we have 2 minus D, 2 minus D, Q2 over Q1. I'm sorry for the sloppiness, I'm writing on a new tablet, it's getting getting used to. Okay, so now we have 2 Q2 Q1 minus D Q2 Q1 equals D. D Q2 over Q1 equals D plus D Q2 over Q1. Then we have 2 over, 2. If I just write it out, it's going to make way more sense. So then you have your, take that to the other side, right? And then it's 1 over all of that. Okay, so when I plug this in, I get about 0.732 meters, which, looking here, makes sense. So if this whole thing is 2 meters, and I was estimating, just without even doing any calculations, that it was going to be less than half, 0.732 meters makes quite a lot of sense to me. Okay, good. Moving on to the next problem. Number 33. So let's look at the book and see what we got. We have 3 charges sitting around a ring. They're all equal in charge. This is 0 degrees. Our first one is at 30 degrees. The next one is at 150 degrees. And this one is at 270 degrees. We want to know what is the E at the origin. Well, if you notice, we're told that all Q's are equal. Q1 is equal to Q2 is equal to Q3. So those are equal, and they're also equally distant apart. This is 120 degrees, this is 120 degrees, and this is also 120 degrees. So, just intuitively, we could know that E is equal to 0 at the origin, because we're going to have E fields equally distant and equal strength pushing in at each other at the same point should give you 0. You can show this more explicitly. So we want E1 plus E2 plus E3. We know that they're in equilibrium. So we have x components for this charge over here and this charge over here. Right, we're going to have an x component. We also have a y component for both of those. So we have E1x cosine 30. I need to keep scrolling, so I would recommend drawing your own diagram so that you can see what's going on. Plus E2x cosine 150. And there's no x component for the third charge. Well, these actually just come out to be, this is E 1/2 minus E2x 1/2 equals 0. So E1x equals E2x. Right, and then so that's a little less insightful, but if we do the y components, we have y components for each thing, so we sum up the y components. We're going to have a negative y component for the third charge at 270, and sine 270 is going to be negative, so that works out. So E2y sine 150 plus E1y sine 30. What does this give us? This is going to be -1. We know that E1 and E2 magnitudes are equal because we found that out in the previous equation. So now we have we'll just call it E1. Well, all the magnitudes of E's are equal, because that's what we're told in the beginning. So, because the charges are equal. So, we have sine 150 is negative 1/2. Sorry, that wasn't working. It's actually positive 1/2, sorry. And then plus sine 30 is also positive 1/2. And so if you sum those up, you get 0. And so that shows that the electric field is 0, which is what we said is intuitive at the beginning. And I agree with that still. Okay, the next problem. Number 58. Just looking at the book here. So we have a plastic ball suspended in an E field. It's a charged sphere, essentially. That's what we're saying. It's a charged sphere suspended in an E field attached to a rope. It makes an angle with the horizontal. The E field is equal to, 1 times 10 to the 3 newtons per coulomb. The mass is 2 grams. The length is 20 centimeters. And the angle is 15 degrees. We want to know what is the charge on the ball. Okay, so we do know that an E field is K times the charge over the distance. Excuse me. We also know that we could set up a force diagram, which I think is probably the one of the better ways to go for this particular problem. Okay, let's just do that because it'll be a little more fun as well, right? So we have a tension force, Ft. We have the F electric force, and then we have our weight force. So we're going to have a y component, and an x component for the tension. And so we know it's suspended, so it's just in equilibrium, right? So let's sum up the y forces. We have negative mg plus fty cosine theta equals 0. That gives us ft is equal to mg over cosine theta. Okay, now let's do the x. Let's sum up the x components. So now we have negative ftx plus fe, which is equal to ft sine theta equals q times the E field. We're given an E field. Sorry, plus. We're given an E field in the beginning, so that actually makes sense. That we do it this way as opposed to breaking it apart like I did in the beginning. Okay, so now we have q times E over sine theta. Okay. There was a negative here, so I'm just checking. Again, double check your signs. I'm going kind of quickly through this, so it's possible I made a sign error. But I think, so now we're in a position that we can actually solve for the charge, which is what we want. Because we have mg over cosine theta is equal to qe over sine theta. So then what do we get? We get q is equal to negative mg tangent theta 1 over the magnitude of the electric field. So this is the answer for that. Alright, so that's the end of discussion 2.